First term we're going to look at, I think everybody in this class has heard this term, and it's intersect. Okay? We're going to just briefly talk about that term just because every other thing we talk about today basically depends on something about how lines intersect. The lines that cross each other intersect. That's the first word. Like I said, I think everybody in here knows. Okay, next term. I like to think of train tracks. Lines that go in the same direction but never touch each other are called parallel lines. So a lot of times when we designate lines, we will use lowercase. So in this case, lines L and M are parallel. I mean, if you think about train tracks, it's a good analogy because if they were to cross each other, the train would wreck, right? In order for the train to be working correctly, those lines can't touch and they have to be the same distance apart so that the wheels on the train, or I don't know if you'd call them wheels, so the train would actually travel correctly. We don't have any train tracks in this town, do we? There are?
Yes, so that we get it to above the gravity down, you don't gotta point it out.
No, I'm just wondering if there were. I didn't know. If you think about parallel lines, if they were to travel in different directions, and it's two-dimensional, so say this line right here, let's say it just went up, just slightly cocked, just twist it a little bit, then they would eventually touch, right? At some point, maybe not where we can see, they would eventually cross. So they have to be going in the same direction in order for them to be parallel. So it's just like train tracks. Lines L and M are parallel. Don't necessarily need to write that down. Just make sure you have this term. Another good example are latitude lines, like on a globe or a map. Those are parallel, right? And longitude lines. Yep, lines on the flag. A lot of different examples. Next term, one that's not so common, so some of you might need a refresher on this one. Lines that cross at a 90-degree angle. Okay, so lines L and M. Now, if they cross at 89, they're not perpendicular. It has to be exactly 90. Forms a cross. If you think about it, perpendicular is the opposite of parallel, right? Parallel, I guess you could kind of say they're at a 180 degrees from each other, but they don't touch. It's probably a good definition too for parallel. For perpendicular, for the simple fact that they're at 90 degrees, they have to cross, right? At least in two dimensions. The reason why we're going over these terms is because we're going to look at special types of angles. We're going to look at a term called transversal, which is where I know for a fact when you take the end of the course test, that's going to be on there. But a transversal is when a line crosses through two parallel lines. And there's a lot of different terms we're going to learn in the next week that are important. So that's why we're going over all of these simple terms. So when we get to those angle definitions, you'll know what's going on. Any other comments about perpendicular lines? Of course, you can look at a room where walls meet and ceiling meets and stuff, you can see perpendicular lines. Okay, so taking a look at this diagram, you could maybe picture that as a little shed or something, right, with a leaning roof. But if you look at line L and line M, so skew lines basically exist only in 3 dimensions. If you look at those two lines and you imagine them going out, so imagine if this line keeps going this way and that keeps going that way. Imagine the same for the red one. They'll never cross each other, okay? And they are not parallel. So the definition for skew is 2 parts. They're not parallel, but they never cross each other. That's what the word skew means. So the idea is if I drew a line here, okay, let's say we call that K, K and M would not be skew because they are parallel. So to be skew, it has to be 2 things, not parallel, and they don't touch each other, which is why they pretty much has to be in 3 dimensions, because if you think about it, if you tried to draw 2 lines that weren't parallel to each other in 2 dimensions, say something like this, they're going to cross down there, right? So skew can really only exist in 3 dimensions. First example, it's really multiple examples, but the same diagram, just to simplify things. We're going to answer some questions together. Then I'll give you the assignment. Like I said, today's pretty simple and short. But so we got the same diagram, although I just took and labeled each individual line on here a different letter for a different line. So we got basically J, K, L, M, skip to P, R, S, T, and V. Okay? And there's more than one answer, so we might just put more than one answer for each of these. So let's name 2 other skew lines. Looking at this diagram, you want to share, Vance? R and P, well, they're parallel though. If you look at R and P, if you imagine that to being the roof, they would be parallel. So to be skew, they can't be parallel and they can't touch. T and K, yes, that will work. Okay. Now T and K are skew because they aren't parallel, right? And they don't cross. Any other pairs? How about S and J? So if you look at S and J on the diagram, they don't cross and they're not parallel. And there's probably more answers, but we'll just do those 2, okay? Everybody clear about skew lines? Name 2 parallel lines. We'll just use that example, R and P, right? So R and P are parallel. They go in the same direction. They're both, you could say they're pointing east. That's fine. R and P. Okay, a lot of other, you could say S and M. S and M are also parallel based on that diagram. All right, 2 perpendicular lines. What's the S and T, good, right? Or you could say S and R. They both form, see if I can label this, they both form 90-degree angles. S and T or S and R. You could also say J and R, yeah, I think that would be, yeah, even though it doesn't look like 90, I guess if you were actually in, well, would that be 90 degrees? Yeah, I guess it would be. I'm trying to picture the actual shed that looks like that. Yeah, I think it would be 90. On the diagram, it doesn't look like that way based on the perspective. Definitely K and V would be 90. But just looking at the actual diagram, these would be the 4 that would be obviously 90. All right, lastly, name 3 intersecting lines. Who wants to raise their hand and share that one? 3 intersecting lines. I'll go ahead and do it since somebody wants to speak up. R, J, and M. They meet at that point right there.